This question is from GATE 2014, Mechanical Engineering paper, Set 1, question number 8. Critical damping is option A, the largest amount of damping for which no oscillation occurs in free vibration. Option B, smallest amount of damping for which no oscillation occurs in free vibration. Option C, largest amount of damping for which the motion is simple harmonic in free vibration. Or option D, smallest amount of damping for which the motion is simple harmonic in free vibration. Let's see what it is. So for a critically damped system, that is, the damping coefficient C of the system is equal to the critical damping coefficient Cc. And that is why it is a critically damped system. Following points are applicable. First is the response of the system decays exponentially. As the response decays exponentially, it happens in the initial phase itself, and because of that, there is no complete cycle of oscillation. So it's not basically a oscillatory motion. No complete cycle of oscillation. And here, the response decays exponentially means the response tend to 0. The response over time will tend to 0. So there is no complete cycle of oscillation for the critically damped system. Before the cycle completes, the response decays to 0. So depending upon the comparison between damping coefficient of the system and its critical damping coefficient, we have two other types of systems. So if C is greater than the critical damping coefficient, it is called overdamped system. And if C is less than Cc, we call it to be underdamped. So when the damping is higher than the critical damping, we have an overdamped system. That means the response decays faster to 0 than the critically damped system. And that is why we say the minimum damping for which response will decay to 0 is the critically damped system. And that is why we say that minimum damping for which no oscillation will occur in the system is nothing but the critically damped system. So let's say if we compare the critically damped system where Cc is equal to C, any value of damping constant which is to the higher side of the critical damping, there is anyway no oscillation, while on the decreasing side where the damping constant of the system will be less than the critical damping, there will be oscillation. And that is why for this particular system, this damping constant value is minimum. Minimum damping for which no oscillation will occur is called the critically damped system. Let's mark the answer now. Therefore, our answer is option B. Smallest amount of damping for which no oscillation occurs in free vibration is called as the critical damping. To learn more about damped free vibrations, you can refer to the NPTEL video, Module 2, Lecture 6, L6, Damped Free Vibrations, Definition of Critical Damping and Problems from the course Soil Dynamics by Dr. Deepankar Chaudhary. He is from Department of Civil Engineering, IIT Bombay. I hope this solution will help you clear your doubt. Thank you.